let us have a look at the observed changes of the hydrological cycle, of the distribution of precipitation on Earth, okay, of changes. Which regions get wetter, which regions got drier on Earth. That's a relatively short presentation. Okay, so we look at all data that we have, and we compare the precipitation between two periods. One is the period of from 1901 to 1960, putting all observations that we have together, and we compare it with the period between 1986 and 2015. Okay, put all the data together and produce a map, and this here is in unit of inches. And the change in precipitation, and we're talking about change in precipitation per year. Okay. All right. Good. Let's have a look at the pattern. You can see that there are some regions which became wetter and some regions which became drier. Okay. And this is an indication of possible future changes. Okay. It is linked to changes in the atmospheric circulation and in the amount of water vapor that the atmosphere can hold. Okay. And some aspects here are also linked to changes in the cloud chemistry. Let's have a look at this pattern here. So the green areas correspond to a wettening effect. These parts get wetter. And the yellow-brown tones refer to getting drier. Okay? Less rainfall. And let's have a look at the map. And something that you not sure whether you would anticipate that, but you would expect that actually, wow, the wetter regions get wetter and the drier regions get drier, which is sort of represented here in the data. You get some significantly, or you got some, this is observed data, you got some severe rainfall reduction. Okay. Over Africa, in particular here the region on the west coast, and over Central Asia a big decrease. Okay, and that's particularly concerning, these type of trends. Okay. All right. In contrast, Northern Hemisphere, mid-latitudes, Northern America, Northern Europe, Northern Asia, all experience increases in precipitation. Okay. Over South America, you have some contrasting features. Some regions have a drying effect, some have a wettening effect. But again, the desert regions, they stand out. So the trends are not considered to be statistically significant because of a lack of data coverage early in the record. So there's a huge data gaps, and that's one of the problems here. We don't have enough rainfall data globally. Okay. All right, let's have a look at the extreme events, and I showed this before. Okay, just looking at two aspects. How have the average number of floods changed, and this is shown here on the left, in this left diagram, and always comparing one decade with the next. Okay, you can see decades per decades here on the x-axis, and the average number of floods per year on the y-axis. And you can see an increase in most regions, from Europe to Asia, America, and Africa. But in the end, there's a decrease. There's some decrease happening. So we don't fully understand. We don't fully understand the variability of floods. There seems to be an increase of flooding events. Okay? We can also look at droughts, and compare the number of extremes of events per year in terms of drought events based on some threshold in rainfall. And you can see that there are regions where you have increases in droughts. So it looks like the extreme events associated with the hydrological cycle are increasing, both in terms of floods and droughts. Okay, but this is something, again, you need to watch out for the next decades. That's already the conclusion of the second part of this lecture.